It is well past time we took a fresh look at road travel in the UK and asked some basic questions about cost and value. Currently we spend in the order of £300 billion a year, predominantly to move people from place to place. For context, the annual cost of the health service is about £180 billion. A large chunk of the cost is money for vehicles and parts that flows out of the country, negatively impacting trade balance. So, is the money we spend on road transport well spent? For many of us, rush hour is a painful experience with average commute times of over an hour, average journey speeds of less than 20 miles per hour, and a high level of journey time variability. It can be a challenge to find suitable parking, and costs are sometimes extortionate. If we are unfortunate enough to use public transport, the situation is even worse. Buses are infrequent, slow, and for the majority only go approximately where we wish to travel. Public transport is second class, mildly unpleasant, and probably a virus transmission vector. Whilst there have been many improvements in vehicle and road safety over the years, the Achilles heel is always going to be human behavior. There are far too many deaths and injuries caused by accidents. The byproducts of combustion from petrol and diesel engines are literally killing thousands of people each year, making tens of thousands sick, and constitute over a quarter of the total UK CO2 emissions. In summary, the vast amount of money spent each year on road travel fails to deliver what might be considered a reasonable set of objectives. Surely, given the level of failure, the amount of people impacted, and our apparent technical prowess, we must have the capabilities as a society to improve the situation. Everyone by now has seen or heard about autonomous vehicles. Many new cars now come with some level of driver assist, and there are ongoing trials underway to test more advanced autonomous technology in the real world. However, whilst full automation will undoubtedly come with benefits, as we will discover, there are inherent limits to these. A new Level 6 is proposed that goes beyond individual vehicle control and considers all vehicles and the road configuration as part of an overall system, in which there is no human driving possible. The geofenced area shown in red in the example would be reserved for centrally controlled vehicles only and allow for traffic rules to be flexible in real time as demand changes. That requires accurate ongoing vehicle positioning, i.e. beyond comprehensive and consistent human capabilities. A larger area outside of the central control region would form the boundaries of operation of a shared public transport vehicle fleet. Each junction in the central control zone can be considered like a gear wheel whose speed regulates the flow of traffic and ensures there can be no collisions. Vehicles reach junction entry points in alternating pairs at set time intervals. They then follow paths that are designed to allow both to cross safely without stopping. In this way, traffic can flow in all directions unimpeded, and there is no requirement for traffic lights or stopping at intersections. Traffic today is required to stop at intersections for both pedestrians and other traffic. Typically, this might mean traffic only flows for 1/3 of the time. Level 6 dispenses with the requirement for traffic lights and allows traffic to flow for 2/3 of the time in the same junction. Today, in the event of roadworks or other lane blockages, traffic can quickly become bottlenecked. With central control, traffic is coordinated to mitigate the impact. Most urban journeys today consist of some combination of normal driving and delays caused by other road users, traffic signals, and flow restrictions. There is also usually a need to park the vehicle and often some contingency to ensure a given final destination arrival time. Level 6 system automation eliminates all unnecessary delays and reduces average commute times by an estimated 45%. By replacing buses with a local fleet of mainly single occupancy, long design life vehicles, public transport can be both low cost and significantly better than that currently on offer. It is hoped in this way to encourage more people to switch away from car ownership. Single occupancy vehicles provide the potential for a higher density of vehicle flow during peak times. Today, our road systems respond to traffic demand in a non-linear way. Initially, traffic flows freely, but as more vehicles enter the system, the output begins to decline. At a certain point, gridlock occurs. Even with large-scale adoption of fully driverless vehicles, the response, whilst better, would be similar in shape. Level 6 traffic control system behaves somewhat differently. Output increases linearly with demand until a plateau point is reached. Wide adoption of single-occupancy fleet vehicles further increases overall system capacity. Trying to fix transport and pollution issues by restricting use is always going to generate annoyance and pushback. Partially solving one problem whilst simultaneously creating others is a less than perfect solution. Full adoption of Level 5 autonomous vehicles is expected to improve some of the issues associated with personal transport in the UK today. It will speed up journey time to some extent, it will be significantly safer and have some positive impact on carbon emissions assuming electric or hydrogen power. However, for those unable to afford what are likely to become more, not less expensive vehicles, public transport will still be buses. A form of ongoing unpleasantness, mass discrimination and inefficiency. Level 6 automation, i.e. system control combined with a locally managed fleet of shared vehicles has the potential to fix all of the issues we currently suffer with urban road transport today. It has the added benefit of increasing our ability to have more face-to-face contact and therefore do more business. Changing the way we move around our towns and cities has far-reaching implications. Not only the more obvious benefits associated with journey time saving. Using data where possible from government sources and applying some basic assumptions around usage, vehicle size, it is possible to roughly calculate a broad range of personal and general benefits associated with adopting Level 6 system automation. There are other benefits for which the current conditions are not measured, such as driving stress, where there appear to be clear linkages which have been identified but no obvious method of calculating the level of improvement. Many of the benefits are disproportionately higher for the least advantaged, something that makes this proposal particularly attractive.